Okay, we're going to call this page 68. Let's see. 67 would be that sheet from yesterday when I was out. If you did not turn that in, by the way, you need to finish it and turn it in because it is going to be a practice grade.
Oh yeah, one of the problems, it was
Two of them come to quadratics when you multiply them out, which is exactly what is on this sheet right here, which is another reason why I was like, I bet we need to refresh quadratics. So we're going to get there. So maybe this will help. So the first four questions are just saying, hey, solve this multi-step equation. You need to remember that before you can solve equations, you have to simplify them. Simplify the right side, the left side, before you start moving things to opposite sides, because that's the process of solving. So like number one, let's refresh you on some vocab words. This is a number multiplying into a binomial. Binomial means two terms. For instance, this is an example. X plus 4 is a binomial because there's two terms in there. Terms are separated by plus and minus signs. You're going to distribute the 8 into the binomial, and over here you're going to distribute the 2 into the binomial. Remember, when you're multiplying, you just multiply the coefficients together, and if one of them has an x and the other one doesn't, then your answer has an x. So for instance, 8 times x would be 8x. 8 times negative 5 would be negative 40. 2 times 3x would be 6x. 2 times negative 8, negative 16. Now I'm ready. There's nothing to simplify. There's no like terms like on the same side. Now I'm ready to move stuff from one side to the other. So we're gonna, you get to go about it however you want. I personally like to move the terms that have the smaller number in the front. I move those because then I run into fewer negatives along the way, if that makes sense. I also always start with x. I always get my x's together first, then I worry about the numbers that have no x, which are, by the way, called constants. So I would subtract 6x, because it's positive, over here under its like term. So that's 2x minus 40 equals negative 16. Yes?
So are we only doing the even ones?
I'm going to do the odd ones as like reminders, teach it if I need to, and then you're doing the even ones as like your practice for a grade.
So do we need to write the ones that you're doing down?
Oh, yeah.
Okay, I was just asking if you said on the even.
Well, the even meaning, I'm going to leave that one and we'll skip the even ones. And then you practice it on your own. Yeah, you need to have the whole sheet. I don't mind giving you the answer for the even ones, number 2 and 4. Number 2, you should come to 8, and number 4, you should come to 19. Okay, so back to this one. Now I have x on the left. I'm going to take the negative 40 and I'm going to move it to the other side by adding 40. So negative 16 plus 40 is 24. Then I'm going to divide by 2. And I get 12. Number 2 will be up to you to do. It is similar. It actually has less distributing. Over here in number 1, I had 2 things to distribute. Over here in number 2, what am I distributing? There's a -1 right there. That looks terrible. There's a -1 right here that is going to distribute and change the sign of those numbers. And then you will have 2 like terms that you can combine before you start moving stuff. Number 3 looks like a hot mess. Just like number 4. While it looks like a hot mess, first of all, the top of that entire fraction is excessive. Like, there's stuff in there that could combine, right? Question, in front of the 11x minus 5, is anything distributing? Can't see. In front of 11x minus 5, what's in front of it? A +1, which means if I distribute a +1 by multiplication, does anything change? No, so there's nothing distributing here. So these parentheses are not even necessary. There is like terms in the top of that fraction that we can combine. What is 3x plus 11x? 14x. And what's 15 minus 5? 10. So I'm going to clean the top of that fraction up, copy the rest, and then now I can see I have this gigantic fraction and it says divided by 2. Don't overthink it. There's 2 ways to do this. Your mind may see it one way, your neighbor may see it a different way. What is the opposite of divide by 2? Multiply by 2. So if I multiply by 2 on both sides, that fraction will be gone, which is what I would recommend doing, because multiplied by 2 is always nice and pretty. So I'm going to write times 2 here, and that's going to cancel, but whatever you do to one side, you got to do to the other, right? So I'm going to bring the 14x plus 10 down. And then what's 47 times 2? Is that 94? Now I have a 2-step equation left. Subtract the 10. And divide by 14. What do you get? 6. Now, I did want to show you that there was another way that you could have gone about it from right here. And it only works, though, if these numbers are nice and pretty. Notice that this was an even number and an even number, and they're both being divided by 2. So you really could have, I'm going to draw an arrow to say or, you could have said, well, that 14x divided by 2 is 7x, and 10 divided by 2 is 5. And you would have just finished the problem from there, and you would still get 6. I would not recommend that way if it hadn't worked out pretty. So, you know what I mean? Like if one of these up here had been an odd number, then I wouldn't want to do that, because now I'm going to run into a decimal. See the difference? All right. 1 through 4, solving equations. Let's look at 5 through 10. No solving here on 5 through 10. We are multiplying binomials, okay? Notice the word FOIL written right here. how many of you remember FOIL from Algebra 1? I remember hearing that first, outer, inner, last. Okay. I have a love-hate relationship with the word FOIL. Here's why. I love it because it kind of helps people remember what to do. And it's simple. First, outer, inner, last. I hate it because it only works when it's a binomial times a binomial. And in Algebra 2, next year, you are going to get a binomial times a trinomial. That's one of the standards. FOIL won't work there. And a lot of kids don't know that. They don't realize FOIL won't work. They think, oh yeah, it works. No, that entire middle term gets missed. So you're going to hear me say, don't use FOIL. Now I say that because I'm going to show you a method that works every time, and then you don't have to worry about next year when you get a binomial times a trinomial. The method is what's called the distributive property. It would be the equivalent of me passing out the first set of papers, distributing, passing out the second set of papers, distributing, right? The distributive property works every time regardless of what the problem is. FOIL only works binomial times binomial. And that's why I don't like it. So I'm actually going to mark through it to say like, yep, that's great. We're not gonna actually use the word FOIL. All right, I'm going to show you two methods. One is the box method. Some of you may remember that. And that just kind of helps you organize your thoughts. And then the other one is just doesn't have the box, but it's the same concept. Okay, so for the box method, the idea is I've got to multiply everything in here times everything in here. To do that, you can use what's called the box method. It helps organize your work. It helps you remember when I need to multiply. And it does work every time. You would just, if you have a binomial times a trinomial, you would draw a bigger box. All right, we're going to draw our box out. You need to leave room above the box to write something on the outside. And you need to leave room to the left of the box to write something on the outside. The box needs to be divided up by the number of terms. I have 2 terms and 2 terms. So this needs to be a 2 by 2 box. You with me? That's why the box works. If it was 2 terms and then 3 terms, it'd be a 2 by 3 box or a 3 by 2. I feel like I'm growing up. Yeah, let's stop. Okay, so then you put one binomial across the top and one down the side. Doesn't matter which one goes where. Does not matter. I'm going to do x plus 8 across the top, x minus 1 down the side. And now what you're going to do is multiply. Use your eyes or take your fingers. You're going to do row 1 times column 1. What is x times x? X squared. X plus x is 2x, but x times x would be x squared. Then, what's x times 8? 8x. Now, row 2, column 1. What's negative 1 times x? Negative x. What's negative 1 times 8? Negative 8. All right, so we have our multiplication in the box. There's one last thing to do, and that's always on the diagonal. I'm going to change colors so you can see where I'm writing. But on the diagonal, you're going to have terms with the same variable that need to combine every time. All right, we're going to write our answer out. So when I multiply these two binomials, this is my answer. Watch how I read it. You always write it in what's called descending order, which is called standard form. It would be x squared. What is 8x minus x? Plus 7x minus 8. And that's the answer. We're not solving, we're just multiplying. I have no clue why it's so freaking cold in here. I'm sorry, y'all. I don't know why. Okay, that's the box method. Now let me show you another method that works every time, and you may actually like this because there's less writing. So everybody lean in, as in like, give me a chance to teach you something you may like better. Ready? This is just the distributive method. There's no box involved. We're just going to write what we get as we multiply. We are going to help us remember what we're doing by drawing lines to represent that I'm doing the first term and the second term. All right, watch. The first set of parentheses, I'm going to draw a single line here to say I'm going to multiply that number, that term, 2x, times everything in here, right? Now how many things are in here? There's 2 things. So I'm going to write 2 lines. All right, so let's write what we get. What's 2x times 5x? 10x squared. Go back. What's 2x times negative 2? Negative 4x. I wrote that too close. Let me move that down a little. All right, we said 10x squared minus 4x. Okay, here we go. So I've taken care of the first term. Now I'm going to go and I'm going to, because it's the second term, I'm going to write 2 lines over here to show me what I get when I take negative 7 and I'm going to multiply it into the entire set of parentheses after it. What's negative 7 times 5x? Negative 35x. What is negative 7 times negative 2? 14. And then the 2 terms in the middle will always combine. If they don't, you've done something wrong. 2 terms in the middle will always combine. These are like the ones that ended up on the diagonal. So we got 10x squared. What's negative 4 minus 35? Yep. And then bring down 14. That is called the distributive property. It is the same thing as the box method. It's just you're not putting your work in a box. You decide which one you like. I'm fine with either way. I normally don't draw the box method up on the board though, because that does require more writing. So I'll refresh again what I did. I just went to the first term and I drew a single line because it's the first term. And I know that that is going to multiply into those parentheses, which has 2 things. So I wrote 2 single lines to say, okay, I'm going to write what I get there. Then the second term, I drew 2 lines to say that's my second term, and it's going into parentheses, and it's going to give me 2 things. Huh? Yeah. Got to multiply by the 2. Number 9, what looks different? What looks different here? They just got the one set of parentheses. We don't have a second one. But what is here? That's squared. That means squared, which means think of like 2 squared. That's 2 times 2. So this is x plus 9 squared, which means, I'm going to write it squared, which means x plus 9 times x plus 9. And then now you would multiply it out.
Sorry.
Okay.
So on number 8, I've been doing the box method since 9th grade, and that's how I did it. So I got when you're supposed to combine like terms, I got negative 2x and positive 2x. What am I supposed to do with that x since it becomes a 0?
Means it disappears.
So
So your answer will be 4x squared minus 1.
okay.
And the reason why, what do you notice about these 2 sets of parentheses? Like, what do you notice? Tell me what you see. They both have a 2x.
And a 1.
They both have a 1.
But one's negative 1.
There's a difference, right, in the sign. This is called a difference. Y'all all need to write this, of squares. And it means that they're so close to being a perfect square, where it's the same thing twice. But there is one difference, and the difference is in the sign in the middle. And what's going to happen is the middle term will disappear every time. So it's the x term in the end. The x term will disappear every single time you have a difference of squares. Over here, this is not a difference of squares. This is actually called a perfect square, because this is x plus 9 times x plus 9, which match completely. This would be called a perfect square. All right, let's do this. Let's leave this at that. Like, you finish the front, because the back is where we are basically going in the complete reverse of what we just did on the front. And if you're a little rusty with multiplying, then I don't need to be throwing it in factoring yet, because that's the opposite. You know what I mean? I need you to be good at multiplying. So what I'll do is I'm going to, because there's only 5 problems. I still need to work number 9, by the way. There's only 5 problems. What I'm going to do is we should do a Kahoot on multiplying binomials. Oh. You should have it the day off.
We should sit down and do a 50-question worksheet.
No, we should have the day off.
I do have the day off.
Doesn't matter.
No, we don't.
No.
What?
Oh, no.
No. It's easy.
No, we got
You only get like 30 seconds to do it.
Do a gimp kit.
Can't you chick? I've never done a gim kit. You want me to?
Gimp kits are fun. Do the one we have to climb.
To climb?
No, I'm awful at that one.
So
it's okay to do it for me every time.
Let's finish number 9. I just realized I haven't finished it. All right. So we got to multiply now. If you're doing the box method, then do the box method. If you're doing the distributive method with the whole lines, then do that. It's up to you. I'd love to see if we get it right together. So this first term is going to multiply into 2 things, and this second term is going to multiply into 2 things. What's x times x? X squared. What's x times 9? 9x. What's 9 times x? 9x. What's 9 times 9? 81. I don't know why I spaced these out so bad. And then my terms in the middle will combine. So I got x squared plus 18x plus 81. All right, you have 5 practice problems, and then I am going to try to find something that would be like 5 more just multiplying, because this is, you really got to know how to multiply in order to be good at factoring.
Sorry. Yeah. All right.
What page is this one?
68.